Alright, what is up guys? This is Ivan from Brainy-Bits.com, and today I'm going to bring you a tutorial and we're going to talk about stepper motors, and we're going to control that stepper motor to move this belt around using an analog joystick that we have here. And we're going to use the very popular and easy to use and cheap Easy Driver module to actually drive the stepper motor. Now, you might hear in the background we're 3D printing some parts right now in our shop. And I'm mentioning that because we're using some 3D parts right now, and we weren't sure if we wanted to offer those inside of our store at Brainy-Bits, because 3D parts tend to be, not the best looking parts, but for some parts, 3D printing it can be very useful. What we're using today as 3D parts in this little project here, as you can see, we have a belt clip. So basically you take your belt, you put it on top of each other, and then you slide this little clip on, and it holds your belt in place. And we're also using another 3D printed part, an idler pulley, and we print those and we put a 624 bearing in it, and it works very good. It's very strong, and that's another part that is very useful when you're playing around with motors. So we're gonna offer these parts in our store from now on, so you guys can grab a couple of those if you want. If you're buying a couple of parts, grab a couple of those and you can do projects like this very easily. And as you can see also, we have brackets here that are cut out of acrylic because we have a laser cutter in our shop, and we're gonna start cutting little parts like this and offer those also, because these are very useful, because we have a bracket here for an EMS 17 motor, and we have another type of bracket here that's also for an EMS 17 motor, but it also can be used for putting idler pulleys and stuff like that. So all these parts are going to be available in our store very soon. We're just doing this because these parts are hard to find, and instead of importing them and all that, since we have the tools here, we'd rather cut them ourselves and customize them and stuff like that, and help you guys out finding the right parts to do your projects. Alright, enough of that. So the way we're going to do this today, we're going to use an analog joystick like I said. So this is connected fairly easily to our Uno right here. And we got the Easy Driver that is connected to the motor. The motor is a bipolar motor. It has only 4 wires connected to it. And the power is provided by our 12-volt power supply. These NEMA motors consume, well, they can work from 12 volt to 36 volts, I believe. And they're rated at 0.4 amps, so 400 milliamps. Like I always say, go to our website, you'll see the schematic. We got more explanation, the specs for these guys and how to connect everything, and a little bit of background on how to use stepper motors. Now, the way we're going to do this today, as you can see, we have a belt looping around here, and we have our belt clip that sits in the middle. Now, what we're going to do, these motors are 1.8 degrees steps, because this guy, the Easy Driver, can be configured to do full step, half step, quarter steps, and I think almost, I think 1/8 of a step. Right now it's configured to do full steps. So 1.8 degrees per step. Full rotation is 360 degrees. So basically dividing 360 by 1.8 gives you 200 steps. What that means is that it needs to do 200 steps to do a full revolution. So we calculated that for the distance of the belt, and we ended up with 2050 steps to do one full length of this belt. So we divided that by 2, that gave us 1025 to sit in the middle. So if by knowing these numbers, now we can know where this will sit in relation to the position. So when the joystick is resting at the middle, it'll be at the middle at 1025. And as I move my joystick, it's going to increase or decrease the number of steps until it gets to 0 or 2050. So it will stop there and not try to loop back around. Now, as you can see, or maybe not see, in this project we have here, we didn't put any limit switches. Now, limit switches are good because if you go beyond a certain point, then it would hit a switch, and we could code that in to say, when you hit a switch, stop. And that's the way that CNC machines and laser cutters and stuff like that do their homing at the beginning. So basically they start moving until they hit a switch, and that tells it that this is the limit that it should go to. Now, we didn't put any of these in here to make it simpler, but you know, do this code and then you could add some limit switches to your own project, so it would do this automatically. So for this project right here, I just need to make sure that when I turn on the power, that my belt sits in the middle, because I coded that when the joystick is not being touched, it will go to, it means that it's at 1025. So I just need to make sure that when I start my project, this is in the middle. So we're gonna go look at the code, get some explanation. You'll understand the logic behind all this. And then when we're done, we're gonna upload the code, come back here and play around with it and move this belt around and see if it works. So let's go take a look and we'll be right back. All right, welcome back. So here we are in the code. So this is the code we're going to use to move the stepper motor back and forth using the joystick. So we'll start at the top. So basically we're defining which pin is connected to what right here. So as an example, the step pin on the easy driver is connected to pin 3 on the Uno. Pin 2 is connected to the direction pin. And MS1, MS2, which will control the amount of stepping, like quarter steps, half step, or full step, are connected to pin 5 and 4. Sleep pin number 7, sleep pin, basically when you toggle that, it turns off the motor. So you can move it, and also it doesn't overheat the motor or the actual module. And we have our X pin, which is the X axis of the joystick, is connected to analog 0. Then we are defining a variable called direction, which will hold the direction clockwise or counterclockwise of the motor, depending on which movement we're doing with the joystick. Then we have steps. Steps is at 1025 because we know that there's 2050 steps to do the whole distance of a belt run. So the middle would be 1025. That assumes, of course, that the belt clip, the thing that holds the two belts together, will be in the middle when we start the program. Now, of course, like I said, we could have added some limit switches, and we could have had the code just go clockwise or counterclockwise until it hits the limit switch, and then by hitting the limit switch, basically we would know that it would be at one end of the run, and we could set that variable here, steps, to 0 or 2050. But for our tutorial, we didn't want to put that in, but that is something that you guys could put inside your project. And then we do the setup of all our pins. They're all outputs. And then we do a digital write of the sleep pin to high. So basically we're waking up the easy driver. That means we're sending current to our motor. If you set that to low, basically you put the easy driver to sleep, and then the current will not go to the motor. And here the configuration for MS1 and MS2 pin to decide if you want full steps, half step, quarter step, or an eighth of a step. So depending on which pin you put high or low, you will choose which one of those your easy driver is going to be using. In our example, we're putting both to low right here, so that equals to full step. So we'll have 200 steps to do one full rotation of the stepper motor. If you put it at half step, then technically what that means that you multiply by 2 the number of steps needed to do a full rotation. So instead of 200 at half step, it would be 400. So this is what we're doing here. Here I'm just putting this as a comment. Basically, digital write the direction pin. Direction pin high means that you want the motor to go anti-clockwise. And if you put it to low, then it goes clockwise. And we'll be using this stuff down here to actually decide which direction we want the stepper motor to turn. Okay, so now we're at the main loop. And the way this works, it's all a while statement. So while the joystick is pointing in one direction or another, we're going to move the stepper motor one way or the other. But we're also going to be using that steps variable here to actually know where the stepper motor is at. So we're starting in the middle of the run, so 1025. So let's take the first one. While the analog, well, we're going to actually go with the middle one. This one here. So while analog read X pin is greater than 401, and so both these statements need to be true for the while loop to run. So an analog reading of the joystick pin is smaller than and equal to 600. So between 401 and 600, which is the middle position of an analog joystick. Because if you go far left, it's 0, and if you go far right, it's 1024. So in the middle, typically would be 512, but sometimes it's fluctuate. So that's why we're doing between 401 and 600. For us, that means that the joystick is at the middle position. So if it's in the middle position, by both these statements being true, and if steps is smaller than 1025, at the beginning it won't be because we set it to 1025. But if it is smaller than 1025, that means that the belt is on the left side of the middle portion. So we're going to do a digital write of the direction pin to low, which means that we're going clockwise. Then we're going to make the stepper move by doing digital write of the step pin high, a delay of 1 millisecond, and then the step pin low. So basically we're switching the step pin high and low very fast, and that's what makes a step in the stepper motor. And then after that we're going to say, okay, we've done a step, so we're going to increase the variable steps plus meaning +1. So let's say the value of steps was, I don't know, 1,000. Well, every time we do a step by doing the high low, then the step is going to become +1. So 1,000, 1,001, and this is going to repeat until this part is no longer true. Step will not be smaller than 1025. It will be 1025 at some point. So there's another if statement here. If the belt is actually on the right side of the middle, meaning the steps is bigger than 1025. So if the steps variable is bigger than 1025, that means the belt is on the right. So we're going to do a direction pin of high, which means go anti-clockwise. So we're going the other way. But we're doing the step portion the exact same way by doing high, delay, low, delay. But now we're going to do steps, the variable steps minus, meaning -1, until we reach that 1025, which is the middle, right here. So as you can see, this part is repeated. All these while loops are doing the same thing, but they're reading different values for the joystick. Like if you take the last one here, 900 and 1024, that means we're pushing the analog joystick all the way to the right. So then if the steps is smaller than 2050, which is the right side limit, then we're doing the same thing here, plus. But in this portion, since this is the end of the run, we don't have to do if steps is greater than 2050 because it will never happen. And the same thing for the beginning here. This is the other side of the belt on the left side. So we're only doing one if statement, if the step is greater than 0. We don't have to do if steps smaller than 0 because that will not happen also. So there you go, that's the way we're doing it basically. It's just with while loops. But we need to make sure that we start at the middle, because we don't have limit switches and all that, so it can't know unless we put that little belt clip that we saw in the video in the middle of our run. Then this will work. If you wanted to make sure and not have to position your belt on your own, then limit switches would be the way to go. So we've done everything here, so we're gonna go ahead and verify our code and upload it to the Uno, and let's go take a look and try it out. Alright, so we're back. We uploaded the code we were just looking at to the Uno, And where we're going to do this, I already applied power to the easy driver right here. So it's receiving 12 volts right now. And I'm going to plug in the Uno now. Now, like I said, like you saw in the code, we need to make sure that when we start this project, that our belt clip sits in the middle of this of the project. Because when I apply power, it's going to assume, since the joystick analog value is at around 512, that our belt is in the middle by default. Like I said at the beginning, you could put limit switches, do a homing in your code that it would start going clockwise if your limit switch is here until it hits the switch, and then you would say that is the origin or 0. So right now, for simplicity, we're just doing it this way, but you could improve on this project a lot, actually. So I'm going to plug in the Uno now. And there we go, we're plugged in, ready to go. Nothing is moving because I didn't touch the analog joystick yet. So now it's assuming that the position is 1025. So I'm going to start, I'm going to move just a little bit to hit the first limit, which is around the middle here. And there we go, it stopped at that part. I'm going to release, comes back, go the other way, come back. Let me try to get this guy a little bit higher. There we go. So let's go again. First, go all the way, stops, you see, that's fine. Release, comes back, and the other way. First, and one more, and all the way, and release. And there you go. So let me remove this guy here. Now, as you can see, it responds fairly fast. Now if I go here, a little bit less, it stops at our first while loop, goes all the way, stops, and I can move it around like this. So there you go. We simplified the code as much as possible. We're not using any libraries at all. We're just using coding to actually step our motor back and forth, clockwise or counterclockwise. And it kind of knows its position in relation to the belt. Like I was saying when we looked at the code, the easy driver has a lot of pins that we're not using right now. There's M1 and M2 to select if you want to do half step, quarter steps. Right now we're doing full steps. And there's a sleep pin also that I could have connected to the joystick push button. So as I push down, it would go to sleep, release the motors, because right now I can't move them because the motor is getting, I'm looking at it right now, 0.32 amps. And when I move, it's using 0.13 amps. And when I release, and when it gets to the resting position, it's getting the full power to prevent it from moving. So we could use those, you could use those to actually make this code even better. So there you go, guys. I hope this helps you comprehend a little bit more how to control a motor using a Uno and an easy driver. This is by no means the only way to do it. This is just an introduction how to code for the Uno to actually control a little motor like that very easily using the easy driver. So there you go, guys. I hope again this helps you. Like I always say, go to our website Brainy-Bits.com. You'll find the schematics, all the parts that you see here. The 3D printed parts, the laser cut parts are going to be available in our store very soon. We're just cutting them right now, making sure they're good. And, we're putting them in our store to help you guys find, hard to find parts and, make your project making a lot easier. So until next time, my name is Ivan, and I hope to catch you guys real soon. Take care.